So we're used to thinking about code as text, and that kind of makes sense because when we're, editing or writing code in the first place, we are working with the code in its textual form. But for most interesting things that we want to do with code, it is necessary to have the code in some more structured or processed form. So I'll give a few examples. So supporting accurate incremental compilation, that requires that you represent the code in a more structured way where you know the dependency graph of all the definitions in the code base. And so you know when a change is made, what things need to be recompiled. Another example is supporting accurate hyperlinked code browsing. So, to be able to click through to the definition of something. For that, we need to not just have the text of the code, we need to know what names refer to and what different symbols in the code refer to. And I could give other examples as well, but most things that you want to do with code, which are interesting, kind of require more structure than just the raw text of it. And so the idea behind Unison Share is, well, why don't we just store code in a more structured way in the first place? So instead of storing code as a collection of text files, why don't we store it in a database? And why don't we store even individual definitions in that database as their abstract syntax tree? So where everything has been fully resolved, we have a perfect understanding of the dependency graph of the code, and we can use that to implement all kinds of neat features. So I'll give a couple examples. So here is the basic code browsing experience on Unison Share. So I have a project open here, and on the left-hand side, we can see this is the namespace tree for the project, and so you can browse through your definitions in your project that way. There aren't really files in this model, so instead your project is a collection of definitions which are grouped into namespaces, and you can open up individual definitions rather than whole files, and you can arrange those definitions, in this code browser however you want. When you open up a definition, like here I've opened up the definition of list.map, the code that you get to see, it's all hyperlinked. You can hover over syntax elements and get syntax hints if you're unfamiliar with the syntax. You can hover over any of the functions that are used here, and you can see their type signatures. You can click through to any definition, and it will open up that definition in this view. You can expand and collapse views and close them and so forth. One neat thing is that even the documentation that we're seeing here is actually is hyperlinked as well. So we're not just looking at just some rendered markdown file. We're actually looking at code that is actually live, that's been type checked, and we actually have the abstract syntax tree for this code, and we can click through to the definitions and open it here. So that's, I'd say, overall nice for browsing through code and exploring it. Another place that a more structured representation of the code helps is when doing code search. So you can certainly do code search by just treating code as text and doing basically full text search on the text of the code. But I would say that the results that you get from that are not as good as they could be. So I'll just give an example. This is looking at this is some code search that I did on GitHub. I entered the query list.map, and I'm looking for Elm code with list.map as the query. And it certainly gives results that mention list.map, that sequence of characters, but there's a lot of results, and this top result it looks just to be some random Elm project that happens to use list.map somewhere in its implementation. So on Unison Share, if you do a search for list.map, the first result is the source code for list.map, because that's often actually what you want when you're doing search. Is I'm looking for the code and/or docs for this function that I'm using. And what's interesting about code search is that there's actually kind of two things that the user might be doing. So one is they might be doing like what I just did, where they want to find the code or docs for a definition. But And that for that, what we showed is nice. But the other thing they might be doing is looking for usages of a definition. Neither one of those things that they might be doing is best served by just doing full text search. If you actually want to do find usages, doing full text search is kind of not, that's not the way to do it, because that's not accurate. You may have a place where list.map is actually being used, but it's being referenced with an unqualified import. So the actual text that appears in the code is just map rather than list.map. And so a full text search wouldn't find those usages. And the other thing is list.map might appear in, say, a text literal, which is not actually a usage of the function list.map, whereas full text search really has no way of distinguishing between those two things. So representing the code in a more structured way lets us do things like search and find usages in a perfectly accurate way. And the other nice thing is that the implementation is much simpler, actually. So we don't actually really need to do anything fancy because the information is sort of already represented in the code database in a way to make it easy. Last thing I'll just show is not only can we search for definitions by their name, but we can also search for them by their type. So I can search for the type, this type, and I can punch it in and get a whole bunch of results that match that type. So suppose I don't know, I want to find list.take that way. I can even mix and match. I can say, like, I can enter, say, a fragment of a type and a fragment of a name, and it will combine those two pieces of information to, give me good search results. So these are just a few examples of just some of the things that you can do with a richer representation of code. And we make use of this to provide a nicer experience and pretty rich functionality for a lot of code editing and code exploring tasks on Unison Share. So Unison Share is a great place to host code and collaborate on it, and it has a growing set of features that are based around this idea of representing code in a database in this more structured way.